Hi, everyone. Welcome to the MLflow hands-on session. In this session, we're going to talk about what MLflow is and how it works. And we're going to see a live demo. We're not going to do a lot of talk, but like more of understanding the functions and what the utilities of MLflow are. And we'll also understand how Databricks is connected with MLflow. And finally, we'll also look into deployment of the models using containers on Azure, right? So with that said, let's get started. So basically, this is a Databricks worksheet, okay? This is hosted on Microsoft Azure. So you have to go to databricks.com and create your account and link it with your Azure subscription or AWS subscription or Google. In this particular case, I have linked it with Azure, as you can see. And that's why you see this Microsoft Azure label over here. Now, having said that, this is a basically called as notebook, similar to your Jupyter notebook. It's created on the cloud itself. It's created on Databricks cloud. So it's easier to manage because everything is running off the cloud, and it's not like running on your local machine, which means a lot of installations, etc., can be done pretty easily. And as you can see, it looks and feels almost like your Jupyter notebook with all the functions and all the buttons and everything. It's got this magic, commands as well, where you can put some content and you can label as such, etc. With that said, let's get started. So basically, this is the first piece of code where we are creating the Azure ML workspace, right? So these are this is the piece of code you want to run on your notebook. So I'll be providing my GitHub link for the same, so you don't have to worry about it. You can just change some of the settings and you can get started on that, right? So I've already run this piece of code with my subscription ID, which is obviously removed here. So with that, when I did that, you can see that there's a new workspace that is created here, right? You can see that, okay, you can see that the new workspace is created, and everything else is also created, right? Okay, now let's go to the important piece of code, which is basically ML flow, right? This is where you're creating an experiment, and then there's a bunch of other information and parameters that you need to understand as a part of ML flow, right? Now, for the next 10 minutes or so, we're just going to talk about ML flow. There are 4 components of ML flow, which is basically the model tracking, then experiments and deployment, and finally serving, right? So we're going to talk about step by step, and we're going to keep it very easy so that it's easy to understand. All right. Okay. So as you can see here, this is the first important piece of ML flow, which is an experiment, which is called an experiment, right? So essentially, the way to think about it is this. Let's just say that you've created a machine learning model and you're tweaking the hyperparameters, and then you're trying a different bunch of hyperparameters, and you want to kind of be able to compare them all, right? So the umbrella of that model is called an experiment. So essentially, you create an experiment and you're now running multiple parameters within a given model. Now, having said that, you can also run multiple models under the same experiment. So there is no hard, fast rule that you have to create a different experiment for every different model. But the experiment is more like, hey, I've created this experiment. I'm going to compare the different runs of this experiment and see which is doing better, right? And that's the kind of logic there. So it all starts with that high-level experiment, labeling, right? So once you have created an experiment, then you get what is called an experiment ID. From there, you can actually see, hey, what is the artifact location? Essentially, where will all my ML flow artifacts reside? And this is the link they will reside, right? And these are the different tags that MLflow provides. So essentially, owner ID, source name, whatever, email, etc., etc. Yeah. So this is basically all the different user information that might be useful. this is extremely important. It took me a lot of time to kind of get this piece of code from internet. So very useful piece of code there. Now, so obviously the two most important things of an experiment are experiment name and experiment ID. And we'll see why those are very important. Okay. Now, let's move on to building a model, a diabetes model. So this is a typical, hello world kind of machine learning model. So got it from internet. So we're trying to predict the progression metric based on different, patient metrics like BMI, blood pressure, etc. We're not going to do too much of EDA, exploratory data analysis, in this session. We'll probably cover that in a different session. The focus of the session is to sort of utilize MLflow and see what we can extract from that, right? So this is a typical machine learning model, as you can see here. Now, the small thing, correction I have to make, this is the experiment name needs to match with the one that we've just created. That was the older one, so I'm going to have to input the correct one, which I'll just be doing right now. Okay. Now, this is all I need to do. Now, as you can see in the code, it's all pretty self-explanatory if you're a data scientist, right? So we are just defining the variables, getting the features, and basically doing a little bit of cleaning there. And we're also defining what is the evaluation metric. This is extremely important because evaluation metrics are getting logged or get logged when we run the experiments and do the runs, right? Excuse me. So basically, there's a train test split you want to do. And then once you've done that, you're basically getting your train X and train Y, similarly text X and text Y. So you're getting all of that, and you're going about starting with the MLflow. So this is the key part of MLflow experiment tracking. So essentially, it starts with the statement with MLflow dot start run experiment ID, right? Now the experiment ID is being fetched automatically from the declaration in the previous code, so we don't have to actually do anything about it, right? So you don't have to hard code it, which is a good thing, obviously. And then what happens then is, it's declared as run, and then you have your code there. So the normal, machine learning code, there's no change there. So the difference being, you're going to have to log these metrics. So you have different evaluation metrics like RMSE, MAE, R-square, etc. Now you're logging these metrics and maybe other metrics you want to log. The cool thing about MLflow is that it gives you flexibility to log whatever you want to log, right? So as a data scientist, let's say you want to log all the different hyperparameters because you want to track the evolution of that, right? Maybe you want to track all the evolution of your hyperparameters as you run multiple runs and multiple experiments, etc. So you can define the parameters you want to log, and MLflow will just do as you wish, right? So in this particular case, not only are we logging R-square and RMSE and MAE, we're also logging alpha and element ratio, so that we want to see, hey, how is that evolution happening, right? Now, the other cool feature is that you're basically logging the model, right? Now, you use the model and the log model function, and you're logging the model. This is extremely important. We'll discuss why when we actually get into the MLflow UI. At the same time, we're also defining the model path, so where we want to store this model for that particular run, right? So we're also defining that part so that the model is being stored in a particular place. That is also very important. We're also defining a run ID based on the run info. So we're storing all of that, and we are creating what is called as model URI. So using the model, the runs information, we are creating the model URI. This is also very important. I've run this once, so we will hopefully see some information, but I'm going to run this again to show you guys how the whole MLflow run happens and how the tracking happens, etc., etc. So as you can see, as I keep running this, I've just finished my run. I'm going to run it, and once again, please notice that the run ID this time ends in 87. And if I do it the second time, it's going to be a different run ID. And that's the idea. All right. Okay, just hold on 1 second, guys. Yeah, so the second run is finished. And this time the run ID is OOC, as you can see here. Now this time around, I'm going to the experiment tab, and we're going to check what are the different experiments that we have here. As you can see, the experiment is called like ML flow tracking scenario, right? In this tab, we can see that there's a bunch of runs we have done. There's about like 5 runs that we have done. So what has happened is in this tab, you can see that this run name, this time that it was created, the time it took to run, and the user and the source and like the model name, right? So basically, it's given all the different metrics. In fact, you can also add more metrics if you want to, or you can delete that. That's kind of up to you. So essentially, what is happening is this tab is useful for us to get an idea of what is going on in the runs that we have done. Now, apart from that, there's few other interesting features in MLflow. So the one interesting feature is you can actually pick the runs you want, and you can go ahead and compare themselves. And the MLflow will plot nice little graphs for you, so that you can actually see, hey, what's going on, let's say in a scatter plot or box plot or whatever. There's not much graphing happening here because they're the same runs, the data is the same, the results are the same, so the MA, et cetera, are the same. So that's why you're just seeing a single point. There's not much difference there. You can also scroll down and see how the different the results are coming out for different models. Again, because they're the same exact data and same exact splits and everything, you're not going to notice a difference, right? What we can do for fun is that we can actually go back, and like we can run a new run, and here we can take off the seed, right? Here it says random seed, so we can pick a different seed so that there's a chance of getting a slightly different result. Let's try and see for this run if we can get a different run. All right, it seems to have run. So let's see if this particular run is slightly different from other runs. Yeah. So I'm comparing this run, the latest one, with the last 4 runs, and I'm trying to see if there's any slight difference, because, like I said, the starting stage is slightly different from the newest run. Hoping the results would be slightly different. Oh, wonderful! Yeah. So as you can see here, the MAE is very different for the latest one compared to the last 3. And the reason is that essentially when we remove the random seed, now what is happening is every time it shuffles and picks the data for training test, it's different. It's picking a different shuffle, right? And as a result of that, you get slightly different MAEs, R squares, or whatever. So it's actually interesting. For the same run, you're now for the same model and data, you're getting slightly different results because the split of training test is different, right? Very interesting indeed. And now I think we can even see that, yeah. So we can see that this is alpha and MAE are different. It's plotting for the different runs. It's plotting, and the results are quite different. Okay. Now, if we go back to I can pick a particular run, and I can see what are the details that MLflow is showing us, right? So for every run, it's actually showing us description, parameters, metrics, what are the results coming at, tags and artifacts, right? Artifacts is basically the interesting things about this particular run, right? So what are the items that we can actually store that can be useful or that can help us in recreation of this particular run? So it so happens that you can see that there's a bunch of information here, almost like a meta tag, and then there's a conda YAML file here. So this is useful for recreating this particular package. So essentially, this can be used by a Docker image to create a Docker image, and then can be deployed in the container, which we'll discuss a little bit later. So there's a model pickle file and the requirement tab. Okay. Now here's something interesting. So this button called reproduce run. So what happens is basically, if I click this button, it's going to reproduce this run. But the problem is it will not reproduce it exactly because I've removed the seed, the random seed. So I'll have to actually, not delete that, right? As long as I keep this as a random seed, we can go ahead and recreate this, and it'll exactly come as the previous one because it's going to pick up the same random shuffle. All right. So it's saying something. Okay. So it's just asking me to, go ahead and run it or whatever. So anyway, we'll skip that for now. So it's taking some time. Now, what we want to be interested in is basically the reproduce done. The reason why the reproduce done is interesting is because it basically, like, it's a good measure for seeing if there's a data drift, right? So for example, in the training flow and the test data, let's say you're running after 6 months, you can have the exact same conditions, everything else is same, the hyperparameters are the same, but you can see, hey, is there any change in the data? Is there a structural change in the data, like data drift or whatever? That can be measured directly by clicking this button. Let's just go ahead and run this anyway. So I hope it's going to run it. It's not going to change a lot of things. So yeah, it's just ran. So so you see this, right? I'm not getting that. I don't know why. Oh, okay. Oh, so basically the experiment ID was not defined. Oh, dog. So I'll have to, I can't run it in that one. I can only run it here because the experiment ID is defined here. So effectively it's the same thing. There's not much difference, but it's just that the same, you're going to get it, right? See, now if we compare this one and this one, it's going to show the same exact results. That's the idea, right? See this 51.05, 51.05. That's because we have frozen the random seed states, which means it's going to take the same shuffle. All right. Now this is the interesting bit. Now let's do something else. So let's just take this, right? Now let's register this model. So what do you mean by register? So basically we are saying that, hey, this model is actually pretty interesting. I want it to be served in production, etc. So essentially, it's almost like you try 50 models and then you found a better model, like a challenger champion model, right? So this is basically, I'm thinking this is a challenger. So I wanted to be pushed to production. So as a data scientist, you're saying this is good. Now you push this to what we call as model registry, right? Once you do that, what happens is this is going to get pushed into this registry models. If you go and check out here, it shows the latest version to be version 5. That's because there are like 5 other versions that have been pushed to the registry, but because you push the latest one, the challenger, so the 5th model is what is ready to be pushed into production, right? So as a data scientist, your job kind of stops here. From here on, the ML ops and ML engineers would take over essentially. So basically, they then take this model and put it into production. That's the kind of a high-level end-to-end explanation of how ML flow works, right? So we've started from things like experiments, and we checked out runs. In the runs, we've seen different metrics, parameters, comparisons, graphs. We've seen charts of comparison, how things go about. Then we see the registry model. This is a high-level overview. There's many other integrations that can happen with ML flow. You can directly push a model from your model registry to production. There's many more other things, which we're not going to touch upon right now. So let's go back to the code. And this time around, we will look at how we can actually basically, we've created a model. It's in the model registry, it's sitting in the model registry, and we have a model URI here, right? So it's a run basically. Now, this can be actually used as we can create an image out of this using Azure. And then from there on, we can actually basically push this into a container, right? So essentially, the next few lines of code, paras of code, is going to talk about how we can build a container and how we can deploy the container, right? So basically, there's a function called Azure MLflow Azure ML build image. If you use this function, then you have to put some parameters like the model URI, where exactly the model is, etc., and other things. what is going to happen then is it's basically going to create an image for us, right? Now let's try this. Okay, so the thing is, this takes a lot of time to run. So I'm just going to leave it here, this here, and then we'll go to the next piece of code, and we'll try to see if this finishes, right? Okay. Now so this basically builds an image. Now what the next step would be, once assuming the image is built, you'll have to sort of basically you want to go ahead and attach a web service. You can basically, the next step is essentially deploy it, right? So basically what we are doing is we are taking this image, we're using ACI, Azure Container Instances, and we're deploying this image. Okay, so once that deployment is done, right, the next part is we can actually check if the deployment is, if the inference is working or not. And how do we do that? We just have to get some data from our test data, right? From the test data, we can take some sample, and then we can basically create a, we can push this data, when we take this data and make an inference request from that deployment, right? Now, this is a code that I've pulled from internet. So I've made some changes so you can actually test it on your own. Now, what happens is that this code is basically, this piece of code is a endpoint, right? So it's essentially used for a web service endpoint, okay? The other thing that we could do is basically, instead of deploying it as a simple container, we could put it on a Kubernetes service. So Azure offers what is called as Azure Kubernetes Service, which is basically a managed Kubernetes cluster pod rather, right? So what happens is this has this incredible fault tolerance, and basically it almost has like 99.99% reliability, and so on, so auto scaling and all that, right? All the good features that the modern CI/CD pipelines use. So essentially, so we can actually take this image and deploy Azure Kubernetes cluster, right? So again, the code for that is right here. You can go ahead and give it a try. Now, so as you can see here, it's a simple, first you have to create a AKS compute target, right? And then that creates a cluster, and then you have to sort of put the image on the cluster. The other option is that if you have an existing AKS cluster, you can also call that, and then you can basically connect this image there. Now let's deploy the previously created image to this particular cluster, right? For that, this is the code. So it's like web service deploy from that image. Here you're mentioning the model image. This is the important part, right? So the two most important things are workspace and model image. So once we have this, you can actually take that image, deploy into the AKS cluster. Once that is deployed, you can basically go ahead and pass an HTTP request. So essentially, once you this HTTP request, you would know if the service is basically active or not, right? I mean, as you're getting results or not. Okay. So what if you have to update your model? How do you do that? So the way to again, it's the same thing. So you have to build a new image for a new model, right? Let's say you have a new model, you will have to do a new build. And using the same new build, you can go ahead and update the container on the AKS cluster, right? So again, there's a function called update. Using this, you can actually update. So as you can see, overall, it's not a complicated job per se. So it's as simple as creating an image, building an image, and then deploying. So for deployment, you have multiple options. Similarly, for inference, you have multiple options. So it depends on your particular use case. But this is a high level, this is how things happen in production per se. This is not fully automated. This is the way, you can say it's partially automated. So basically, once a data scientist, registers the model, from there on, you can use this code to push the model. Basically, the next step would be to sort of deploy this new image to the cluster, right? So this is the function for that. This is the command for that. And the last step is essentially cleaning the deployments. So you can basically delete the web services and and the compute cluster. So if you don't want to like keep spending money on the Azure, that's pretty much it, guys. Thanks for your interest in this. So we will be doing next sessions on many interesting topics. like deploying to Amazon cluster and Google Vertex AI. We'll also touch upon a very, very important topic called TensorFlow Extended, which is very important and very useful for the modern data science machine learning pipelines. So thanks once again for checking out. Please check out the other videos in the channel. Thank you. Thank you.